A wormhole tears through the fabric of space in a flash of cinematic light. That image is pure fiction, but the real scientific mystery is far stranger. What if the very first journey through a wormhole did not await us in the far future, but occurred in the deepest past of the cosmos, mere moments after reality began? Today, we embark on a thought experiment across 30 staggering theories about the universe's inaugural wormhole transit. By the end, you will possess a tapestry of possibilities that redefine where we come from and what the cosmos might truly be. We will explore if our universe was born from such a tunnel, and whether the first traveler was a particle, a law of physics, or something beyond matter itself. What single idea about the dawn of time most captures your imagination? The singularity from which our entire cosmos burst forth was not a lonely, isolated point. It was a door. The first theory of primordial wormhole travel proposes that the Big Bang was not a beginning at all, but an arrival. Our entire universe might have emerged from the mouth of a wormhole, a cosmic tunnel that served as an exit ramp from a pre-existing reality. In this model, the initial singularity was not the start of everything, but the terminus of a bridge. The other end, in a parent universe we can scarcely conceive, would have been what physicists call a white hole, the theoretical opposite of a black hole. Where a black hole's gravity is so intense nothing can escape, a white hole violently expels all matter and energy, allowing nothing to enter. The first journey through this wormhole, then, was not a conscious voyage. It was the cataclysmic event of spacetime itself being born. As the fabric of a new universe flooded out from that white hole exit, every particle, every force, every law of physics we know began its existence as part of that inaugural, universe-spanning transit. This theory reframes our cosmic origin story completely. We are not the remnants of an explosion from nothing, but perhaps the descendants of a migration from somewhere else. The echo of that first passage is the expansion we still observe today, the universe continuing to spill out from that ancient gateway. But if our universe was born from a wormhole, where did that wormhole itself come from? The second theory takes us to the very edge of physics itself, to the first incomprehensibly tiny fraction of a second after the Big Bang. This era is called the Planck epoch, a time when the universe was smaller than a single atom and all four fundamental forces were fused into one. Here, the smooth fabric of space and time we know did not exist. Instead, reality was a seething, turbulent ocean known as quantum foam. Picture the surface of a pot of water at a furious boil, but instead of bubbles, space-time itself was churning. At this unimaginably small scale, empty space was not empty. It was a chaotic nursery of virtual particles and antiparticles constantly popping into existence, borrowing energy from the vacuum for a fleeting moment before annihilating each other and vanishing. Within this frothing sea, the geometry of spacetime was not fixed. Tiny rips, tunnels, and bridges in the fabric of reality spontaneously formed and dissolved in an endless, random dance. These were wormholes in their most embryonic form, microscopic portals blinking in and out of existence too quickly for anything to pass through. The theory of the quantum foam nursery suggests that the first traversable wormhole was not built, but born from this chaos. Through a random, incredibly rare quantum fluctuation, one of these microscopic spacetime tunnels did not immediately collapse. Perhaps it was caught in the rapid expansion of the inflating universe, stretched and stabilized before it could vanish. Or perhaps a chance alignment of virtual particles provided just enough exotic matter, with its repulsive gravity, to prop the tunnel open for a fraction longer than usual. That tiny extension of its lifespan could have been enough. In that critical instant, as the universe cooled and the forces of nature began to separate, that one stabilized fluctuation was stretched and enlarged by the expansion of the cosmos itself. What was once a transient speck in the quantum foam became a genuine bridge, a thread woven into the growing tapestry of spacetime. This theory proposes a humbling origin. The first gateway between points in the cosmos was not a monument or a machine, but a cosmic accident, a fortunate flaw in the fabric of reality that became permanent. It suggests that wormholes are not just theoretical possibilities, but natural features that may have been woven into the universe from its first breath. This quantum foam, however, was about to be caught in a storm of cosmic proportions. The third theory takes us to the next critical phase, a fraction of a second later, known as cosmic inflation. During this brief but unimaginably powerful period, the universe did not just expand, it exploded in size, doubling its dimensions over and over again in a microscopic flash. Space itself stretched faster than the speed of light, smoothing out the primordial chaos into the vast, uniform cosmos we observe today. But what if this violent stretching did not create a perfectly smooth fabric? Think of pulling on a piece of taffy or blowing up a balloon. The material stretches thin, and sometimes, under that immense tension, tiny flaws or weak points can become permanent features. In the seething spacetime of the early universe, inflation could have acted with similar force. As the fabric of reality was stretched exponentially, certain regions might have been pulled in unusual ways. The geometry could have folded back on itself, or a microscopic tear from the quantum foam era might have been caught and stretched, not smoothed away. Instead of healing, this flaw was amplified, woven into the very structure of the expanding cosmos as a permanent topological defect. Physicists sometimes compare this to the way cracks form in ice as water freezes and expands, or the way knots can appear in a rapidly pulled rope. The first wormhole in this view was not a tunnel anyone built, but a crack in the foundation of reality itself, a scar left over from the universe's most violent growth spurt. This cosmic crack, once microscopic, was then stretched by inflation to potentially mind-boggling proportions. By the time inflation ended, this natural bridge in spacetime could have been blown up to a scale spanning vast regions of the newborn universe, or even connecting its distant edges. It became a permanent feature of the cosmic landscape, a relic of a time when the laws of physics were being written in real time. This theory offers a compelling origin story. It suggests that the first traversable wormhole was an inevitable byproduct of the universe's own explosive birth, a cosmic accident frozen in time and stretched to epic scales. That cosmic crack in spacetime, however, was not the only potential gateway forming in those first chaotic moments. A fourth theory emerges from the shadows of the infant universe, one involving the darkest objects of all. Within the first second after the Big Bang, as matter and energy coalesced from the cooling fireball, patches of extreme density could have collapsed under their own gravity. These were not the stellar black holes born from dying stars much later in cosmic history. These were primordial black holes, ancient relics that could have formed from the raw, uneven pressure of the newborn cosmos. They would have been scattered across the universe like seeds in the wind, some perhaps as small as an atom yet containing the mass of a mountain. Now, consider the dance of gravity in that dense, crowded early universe. Two of these primordial black holes, born perhaps light years apart in the rapidly expanding fabric, could have been drawn into a fatal orbit. As they spiraled toward each other, their unimaginable gravity would have warped the spacetime around them into a profound, shared distortion. According to Einstein's equations, at the very moment their two singularities, the points of infinite density at their hearts, touched or merged, something extraordinary could have occurred. The extreme geometry could have forged a shortcut, a theoretical tunnel connecting their former locations. This is the essence of an Einstein-Rosen bridge, a mathematical possibility arising directly from the solutions to the equations of general relativity. In this scenario, the first wormhole was not a random quantum fluctuation or an inflationary scar, but a violent cosmic handshake between two of the universe's first monsters. The collision of their singularities would have stitched a bridge between two distant points in the young cosmos, a tunnel born from pure gravitational catastrophe. Yet here we encounter the great challenge of this elegant idea. An Einstein-Rosen bridge formed in this natural way is, according to classical physics, notoriously unstable. It would be a tunnel that snaps shut faster than anything, even light, could possibly travel through it. To be a traversable wormhole, a vehicle for any kind of journey, this gravitational tunnel would need to be propped open, held against the crushing will of spacetime itself to seal the breach. This requires something with negative energy density, often called exotic matter. This is not antimatter, but a hypothetical substance that exerts negative pressure or repulsive gravity. It is the cosmic equivalent of a material that pushes spacetime apart instead of pulling it together. Without a thread of this exotic matter woven into the fabric of the bridge, the tunnel would collapse instantly, making any passage impossible. So the theory of the primordial black hole link presents a breathtaking sequence, a violent birth from the universe's first second, a gravitational dance leading to a collision, and the fleeting creation of a spacetime bridge. But for that bridge to become a true gateway, something else, a strange, repulsive force we have yet to truly discover, must have been present at that ancient moment, holding the door ajar for the first traveler. That exotic matter holding the door open is not just a convenient plot device, it is a mandatory ingredient written into the very equations of gravity by Einstein. General relativity is brutally clear. Any wormhole, whether born from colliding black holes or quantum foam, is inherently unstable. The immense gravity of its own structure would cause the throat of the tunnel to pinch shut in an instant, far faster than any signal could traverse it. It is a bridge that crumbles the moment you try to set foot on it. To prevent this cosmic collapse, you need a countervailing force, something that pushes against gravity itself. This is where exotic matter enters the story. Unlike the familiar atoms that make up our world, which always have positive energy density and attract one another, exotic matter would possess negative energy density. Think of it as a substance with anti-gravity properties. It would repel spacetime, creating a kind of cosmic pressure that holds the wormhole's throat wide open, like pillars supporting a tunnel against a collapsing mountain. For decades, this requirement made wormholes seem like pure mathematical curiosities, beautiful ideas forever locked away in theory because such bizarre matter seemed impossible to find or create. But what if the universe itself provided the key in its first moments? The extreme furnace of the early cosmos was a laboratory for physics we can barely replicate. During the rapid cooling and phase transitions that occurred after inflation, the very fields that give particles their mass and properties were in a state of violent flux. Scalar fields, which permeate all of space, might have undergone sudden shifts, like water freezing into ice. In those chaotic moments, pockets of space could have been trapped in a different energy state than their surroundings. These domains, like bubbles in a cooling drink, might have exhibited precisely the strange, repulsive properties we call exotic matter. They would have been regions where the vacuum of space itself had a different, negative energy. Now imagine one of these stabilizing bubbles, this accidental patch of cosmic anti-gravity, forming at just the right place and time. Perhaps it coalesced around the throat of a nascent wormhole born from colliding singularities or an inflationary flaw. For a brief cosmic heartbeat, this natural anomaly would have done what our technology cannot. It would have propped the tunnel open, counteracting the crushing force of gravity just long enough. In that sliver of time, measured in perhaps mere fractions of a second, the universe's first wormhole transitioned from a mathematical possibility to a physical gateway. It became traversable. The door was not just ajar, it was held open by the universe's own forgotten architecture. This theory offers a profound shift in perspective. The first stable wormhole might not have required a builder's hand. It could have been a perfect, fleeting accident, a cosmic alignment where a gravitational tunnel and a bubble of repulsive vacuum energy found each other in the chaos of creation. The stage was now set, a bridge existed, and it was open, but what or who was the first to cross that impossible threshold? The door was open, but the destination defies all common sense. Theory 6 confronts one of the wildest implications of a primordial wormhole. It might have been a journey to nowhere, or more precisely, a journey back to its own beginning. This is the concept of a closed time-like curve. In our normal experience, time is a one-way street. We move forward along what physicists call our world line, from past to future. But the extreme warping of spacetime within a wormhole could, in theory, twist that line into a loop. One mouth of the tunnel could exist at an earlier moment in cosmic history than the other. Passing through would not just move you across space, but backward in time. Now, apply this to the universe's very first stable wormhole. Imagine one end formed a fraction of a second after the Big Bang. The other end, due to the intense gravitational distortion, opened at a moment just before the wormhole itself naturally came into existence. This creates a staggering logical paradox. Could something have emerged from that future mouth, traveled back, and been the very catalyst that stabilized the wormhole in the first place? It is the ultimate chicken and egg dilemma written into the fabric of spacetime. Did the tunnel exist because something traveled through it, or did something travel through it because the tunnel existed? This loop threatens to unravel causality itself, suggesting an effect could precede its cause, a reality where events bootstrap themselves into existence with no clear origin. To prevent such logical chaos, some physicists propose the Novikov self-consistency principle. This idea asserts that the laws of physics simply will not allow genuine paradoxes. If time travel to the past is possible, anything a traveler does there must already be a part of history. There are no alternate timelines or changes. You cannot go back and prevent your own birth, because your existence is proof you never succeeded. In the context of our primordial wormhole, this principle suggests a mind-bending possibility. The first traveler through the tunnel was not an intruder breaking the timeline, but an essential component of its creation, perhaps a stray particle or a ripple of energy upon exiting the earlier mouth, provided the precise quantum nudge needed to stabilize the bubble of exotic matter holding the throat open. Its journey did not alter history. It was history, a single, consistent, looped event woven into the universe's first moments. The wormhole did not create a paradox. It created a perfect, self-fulfilling circle where the journey and the gateway were two parts of the same eternal moment. That self-consistent loop in time presents a universe that is, in a sense, pre-wired. But what if the wiring itself is still active, still shaping everything we see? The seventh theory proposes a direct link between those first cosmic tunnels and the greatest unsolved mystery in modern cosmology, dark energy. We know the universe is not just expanding, but that this expansion is accelerating, driven by a mysterious repulsive force that makes up about 70% of the cosmos. We call this force dark energy, but its true nature is unknown. What if dark energy is not a smooth, uniform field filling all of space like an invisible mist? What if instead it is a dynamic force channeled through the ancient architecture of the cosmos? Imagine the universe's first stable wormhole not as an isolated bridge, but as a leak in the foundation of reality. In the extreme conditions of the early universe, a flaw in spacetime could have created a conduit between our universe and something else, perhaps a higher dimensional bulk or a realm with different physical constants. The pressure difference between these realms would have caused energy to flood through the tunnel. This energy, with its inherent repulsive quality, would be the very thing that propped the wormhole open, acting as a natural source of the exotic matter we've been searching for. But it wouldn't stop there. This flux would not be contained. As the universe expanded and cooled, this primordial wormhole might have served as a pressure valve, a permanent channel for this repulsive energy to seep into our cosmos. Over billions of years, as more such tunnels potentially formed and linked, they could have created a vast, invisible network, a cosmic circulatory system for dark energy. The accelerated expansion we measure today would not be a background feature of empty space, but the accumulated effect of this energy flowing through these ancient gateways. In this view, the first wormhole was not just a passage for matter, but the universe's first artery, and what flowed through it was the very force that dictates its ultimate fate. This theory offers a stunning unification. It suggests that the mechanism which allowed the first journey also planted the seeds for the large-scale structure of everything. The distribution of galaxies, the great cosmic voids, the very rate of expansion, all of it could bear the subtle imprint of that primordial network. We are not just looking for wormholes as tunnels to elsewhere. We might be living inside a universe whose expansion is powered by their silent, enduring breath. Our universe may have never been truly alone. The eighth theory pulls the camera back from our cosmic cradle to reveal a vaster stage, the multiverse. Here, the first wormhole was not an internal flaw or a quantum accident, but a point of contact from the outside. Picture the concept of eternal inflation, where our Big Bang was just one bubble of spacetime nucleating in an endless, frothing sea of false vacuum energy. Countless other universes, each with potentially different laws of physics, were bubbling into existence all around us. In that chaotic, hyperdimensional foam, these expanding bubbles did not always remain politely separate. They could have collided. When two such infant universes brushed against each other in the greater multiverse, the impact would have been a cataclysm of unimaginable scale. The boundary between their distinct spacetimes could have fused, or perhaps a violent exchange of energy punched a hole through both membranes. That puncture, stabilized by the immense energies of the collision, would have become a tunnel, a wormhole linking two entirely separate cosmic realities. This is not a bridge within our universe, but a gateway between worlds. The first journey through such a tunnel would have been a flood of alien physics. As the two universes connected, their fundamental properties might have sought equilibrium. If one had a stronger nuclear force, or a different value for the speed of light, those attributes could have poured through the gateway, altering the very bedrock of the newborn cosmos on either side. The first traveler might not have been a particle, but a law of nature itself, migrating from one reality to another. Alternatively, the tunnel could have served as a conduit for pure information, a cosmic data stream encoding the structure of a neighboring universe. This theory transforms the origin story completely. The seemingly fine-tuned constants of our universe, the very numbers that allow atoms and stars to exist, might not be random. They could be the result of a primordial handshake with another cosmos, a compromise written into the fabric of reality at the moment of first contact. That ancient wormhole would have been a scar of that collision, a permanent reminder that we are part of a community of universes, forever linked by that first, foundational breach in the wall between worlds. The idea of a universe fine-tuned by a foreign hand leads to a profound and unsettling question: did our cosmos receive a helping push toward complexity? The ninth theory, the anthropic wormhole, proposes that the first journey was not an accident, but a delivery. It suggests the fundamental constants of our universe, the strength of gravity, the mass of an electron, the precise value that allows stars to burn for billions of years, were not random. They were curated. In this scenario, a wormhole in the earliest moments served as a cosmic umbilical cord, connecting our infant universe to a mature, perhaps ancient, parent reality. Through this tunnel, a deliberate influence flowed. This influence might not have been a physical traveler in a ship, but something far more fundamental, a pulse of information, a set of boundary conditions, or a wave of energy calibrated to adjust the very laws of physics as they were cooling into place. Think of a master gardener grafting a branch onto a wild tree to ensure it bears a specific kind of fruit. The parent universe, through the wormhole, performed a similar act of cosmic horticulture, guiding the growth of our reality to produce a harvest it desired, a harvest that could ultimately include stars, planets, and life. This directly invokes a powerful philosophical concept known as the anthropic principle. In its simplest form, the principle observes that we can only exist in a universe capable of producing us. We find ourselves in a universe with the right constants because, well, we are here to observe it. The anthropic wormhole theory takes this a step further. It proposes a mechanism. Our universe is hospitable not by sheer, astronomically unlikely chance, but because it was intentionally connected, at birth, to a source of stability. The first wormhole was the instrument of that fine-tuning. The implications are staggering. It means the conditions for carbon-based life, for water and stable suns, might be the result of a cosmic inheritance. Our existence could be the long-term outcome of a protocol enacted at the dawn of time. This theory blurs the line between cosmology and philosophy, between chance and design. It offers an answer to the haunting question of why the universe seems so perfectly balanced for life, suggesting the balance was not luck, but legacy. The echo of that first, purposeful connection might resonate in every atom of our bodies. That legacy of fine-tuning hints at a universe built with profound precision. Yet to understand that blueprint, we must peer into the chaos where our current laws of physics break down. The 10th theory positions the first wormhole not as a bridge or a tool, but as a fossil. It is a relic from the era of quantum gravity, the holy grail of modern physics. Today, we have two magnificent but incompatible rulebooks for reality. Einstein's general relativity masterfully describes the cosmos on large scales, the warping of spacetime by planets, stars, and galaxies. Quantum mechanics, with equal brilliance, governs the bizarre world of the impossibly small, the probabilistic dance of particles and forces. They work perfectly in their own domains, but when forced together, like at the singularity of a black hole or the first instant of the Big Bang, their equations produce nonsensical answers. They scream in contradiction. The theory that will unite them, quantum gravity, remains our greatest unsolved puzzle. Now, rewind to the universe's first moments. In that inconceivably hot, dense state, gravity was not yet the smooth, classical force we know. It was a quantum force itself, fluctuating and probabilistic, woven into the same fabric as all other interactions. In that primordial soup, the very concepts of here and there were blurred. Distances and durations were not fixed. Under such conditions, the formation of wormholes would not have been a rare, dramatic event. It would have been commonplace, as natural as the formation of particles themselves. Space-time tunnels of all sizes would have flickered in and out of existence, part of the fundamental texture of a reality where gravity itself obeyed quantum rules. As the universe expanded and cooled in a fraction of a second, it underwent a phase transition. Gravity decoupled, freezing into the classical, smooth force we recognize today. In that freezing process, most of those quantum gravitational features, the frothing foam of microscopic wormholes, would have smoothed away and vanished. But what if one did not? What if, through a chance fluctuation or a topological knot in the geometry, a single macroscopic wormhole was caught in the change? It did not dissipate. Instead, it was locked in place, its structure fossilized by the cooling universe. This first stable wormhole, then, would be a cosmic time capsule. Its very geometry, the shape of its throat, the way it connects two points in space, would be encoded with the rules of quantum gravity as they existed in that fleeting epoch. It would be a three-dimensional snapshot of physics in its unified state, a sculpture made from the laws of everything. Studying such an object, if we could ever find one, would be like an archaeologist discovering a perfectly preserved city from a lost civilization. Instead of pottery and tools, we would find mathematical relationships and constants frozen in spacetime itself, the patterns in its gravitational lensing, the way it might vibrate or resonate, could reveal the fundamental equations that elude our particle colliders and telescopes. In this view, the quest to understand the universe's first wormhole is not just a search for a tunnel, it is the search for the original instruction manual of reality, written not on paper, but in the twisted fabric of the cosmos. That fossilized geometry from the dawn of time might hold the key to a modern crisis in physics. The 11th theory dares to connect the first wormhole to one of the most heated debates in science today, the black hole information paradox. This paradox asks a terrifying question: when something falls into a black hole, is all information about that object, its composition, its structure, its history truly and forever lost, erased from the universe? This violates a sacred principle of quantum mechanics, which states that information can never be destroyed, it simply scrambles and transforms. So where does the information go? One of the most radical and elegant solutions is known as the ER equals EPR conjecture. It is an equation of ideas, not numbers. On one side, ER stands for Einstein-Rosen bridges, the formal name for wormholes. On the other, EPR stands for Einstein-Podolsky-Rosen, the trio who first highlighted the bizarre phenomenon of quantum entanglement. This conjecture boldly proposes that these two seemingly separate concepts are, in fact, the same thing described in different languages. It suggests that when two particles become entangled, that mysterious connection where measuring one instantly affects the other, no matter the distance. They are not communicating faster than light through empty space. Instead, they are connected by a minuscule, non-traversable wormhole. Their spooky action at a distance is actually a shortcut through the fabric of spacetime itself. Now, scale this breathtaking idea up to the universe's first moment. The early cosmos was a seething plasma of particles, all born from the same quantum event. It is plausible, even expected, that vast regions of this primordial fireball were deeply entangled with one another. The 11th theory proposes that the first macroscopic, stable wormhole was not an alien structure or a random crack. It was the physical manifestation, the geometric embodiment, of a fundamental quantum link between two enormous regions of the infant universe. As the cosmos expanded and cooled, this entanglement was not lost. It was literally woven into the architecture of reality as a traversable bridge. This provides a profound resolution to the information paradox before the first star ever died to form a black hole. If wormholes are the geometric reality of entanglement, then information never needs to travel across space to be preserved. It takes a shortcut. When matter falls into what will become a black hole, its information is not trapped behind an event horizon. Instead, it is instantly transferred through these microscopic spacetime tunnels, these threads of primordial entanglement, to the entangled partner on the other side, which could be the radiation streaming away from the black hole, or even another region of the cosmos. The universe, from its very first breath, built a backup system. The first wormhole was the prototype, a cosmic guarantee that no story, no particle, no bit of data would ever be truly lost. It means the cosmos remembers everything, and the proof of that memory might be etched into the oldest bridges in existence. The universe's first entanglement may have woven itself into a permanent bridge, but other architects were also at work in that primordial forge. Among the most exotic relics theorized to exist are cosmic strings. Picture these not as strings of matter, but as flaws in the fabric of reality itself, one-dimensional cracks in spacetime that formed as the universe cooled and its forces separated. They are theoretical scars, thinner than a proton yet denser than a mountain range, stretching across cosmic distances. Their gravitational influence is so profound that they could literally bend light around them, acting as gravitational lenses. Now place two of these infinitely dense, thread-like defects in the early universe. As the cosmos expanded, these strings could have moved, perhaps forming a loop or crossing one another. At the point of intersection, the combined gravitational warping would be unimaginable. Spacetime itself would be twisted and pinched into an extreme geometry. According to this theory, that precise, violent knot in the cosmos did not just bend space, it punctured it. The intersecting gravitational fields of the cosmic strings could have torn a hole through the fabric, stitching the edges together to form a tunnel, a wormhole sculpted by pure topological force. This would be a gateway forged not from quantum foam or colliding singularities, but from the very cracks in reality's foundation. The resulting structure would be phenomenally stable. Unlike wormholes dependent on fleeting exotic matter, a passage carved by cosmic strings would be held open by the immutable, permanent tension of the strings themselves. They would act as eternal pylons, their immense mass and structure preventing the throat from collapsing. This means a wormhole born from such an event in the universe's first second might not have evaporated or closed. It could, in theory, still exist today. It would be a fossil from the infancy of everything, a silent, gravitationally charged monument to a time when the laws of physics were still setting into their current form. Finding such an object would be like discovering a canyon carved by the first raindrops on a newborn planet, a permanent feature marking a transient, ancient event. Its enduring presence would offer a direct window back to the era of symmetry breaking, a place where we could potentially observe the raw, sculpting power of the universe's own primordial flaws. A universe made of perfect balance would be a universe of nothing. In the first instance after the Big Bang, theory says equal amounts of matter and antimatter should have been created. These are mirror opposites, destined to annihilate on contact in a flash of pure energy. If that perfect symmetry had held, every particle of matter would have met its antimatter twin, and the entire cosmos would have dissolved into a featureless sea of radiation. There would be no stars, no planets, no us, yet here we are in a reality built almost entirely from matter. Something tipped the scales. Physicists call this mystery baryogenesis, the genesis of an imbalance. The 13th theory offers a radical setting for that critical event, the throat of the universe's first wormhole. This ancient gateway could have been more than a bridge. It might have been a cosmic filter or a particle accelerator of unimaginable scale. Picture the primordial plasma, a seething soup where matter and antimatter particles are constantly forming and annihilating. Now, imagine this chaotic mix being funneled into the swirling geometry of a nascent wormhole. The extreme conditions inside, intense gravitational shearing, violent tidal forces, or perhaps a unique alignment of quantum fields, could have acted like a cosmic sieve. Just as a centrifuge separates substances by density, the wormhole's physics might have preferentially pulled matter in one direction and antimatter in another. One type could have been ejected from one mouth, the other from the far end, effectively sorting the universe's ingredients before they could completely destroy each other. Alternatively, the wormhole itself could have been the catalyst. Within its curved spacetime, the very laws governing particle interactions might have been temporarily skewed. Certain rare decays of fundamental particles, which in normal space produce equal amounts of matter and antimatter, could have been biased inside the tunnel. Processes that favor the production of a few extra quarks, the building blocks of protons and neutrons over antiquarks, might have been dramatically amplified. The wormhole becomes a factory, not just a passage. Every particle stream that passed through it emerged slightly enriched with matter, like ore refined in a furnace. Over countless passages in that early, dynamic era, that slight bias could have been compounded, creating the overwhelming surplus of matter that would later condense into galaxies. This theory provides a tangible mechanism for one of cosmology's greatest puzzles: the asymmetry we see in everything, from the smallest atom to the largest supercluster, might not be a random fluke of the vacuum. It could be the signature of a journey, the indelible mark left on reality by its first passage through a gateway that did not just connect places, but fundamentally transformed what passed through it. The universe we inhabit is made of matter because, long ago, something filtered the cosmic fire. Scale is a persistent illusion in cosmology. While we envision vast bridges for starships, the universe's first stable gateway might have been invisible to any eye. The 14th theory proposes a radical downscaling. The inaugural traversable wormhole was not a cosmic canyon, but a subatomic pinprick, a tunnel existing entirely within the quantum realm. In the seething chaos of the Planck epoch, spacetime itself was granular, and the distinction between a particle's path and the geometry of space blurred. Here, so-called quantum wormholes could have flickered into existence as naturally as virtual particles. These were not tunnels for matter to travel through in the classical sense, but transient rearrangements of spacetime geometry on the smallest possible scale. For such a structure to become traversable, even briefly, it would need to be held open. At this microscopic level, the exotic matter required might not be a strange substance, but a quantum effect itself. The Casimir effect, observed in labs, demonstrates that the vacuum between two very close plates has a lower energy density than the surrounding space, creating a subtle attractive force. This negative energy density is precisely the exotic matter needed. In the early universe, random quantum fluctuations could have created analogous geometries, microscopic structures where pockets of negative vacuum energy naturally formed, propping open a wormhole just wide enough for a single elementary particle. The first journey, then, was not a voyage, but a quantum leap in the most literal sense. A photon, or perhaps a quark, existing as both a particle and a wave, would not have traveled around the tunnel. Its probability wave would have simply found a shorter path through the folded geometry of spacetime, effectively tunneling from one point to another via the wormhole. This event would have been instantaneous and unobservable, a fundamental transaction in the fabric of reality where a particle bypassed the classical notion of distance altogether. This microscopic transit set a profound precedent. It demonstrated that spacetime could be threaded, that shortcuts were woven into the quantum code of the universe. As the cosmos inflated and cooled, these quantum seeds might have been stretched. A microscopic wormhole stabilized by a quantum fluctuation could have been caught in the exponential expansion, its tiny throat blown up to macroscopic dimensions, inheriting its stability from that first subatomic event. The vast bridges we dream of might simply be inflated versions of the universe's original, quantum-scale stitches. Our universe might possess hidden folds we cannot see. The 15th theory stretches the very concept of a wormhole beyond a simple tunnel in space. It proposes that the first stable gateway did not merely connect two distant points in our familiar three dimensions of length, width, and height. Instead, it bridged our entire cosmos with a different realm of reality altogether, a compactified or bulk extra dimension as suggested by string theory. In this view, our observable universe could be a three-dimensional membrane, or brain, floating within a higher dimensional space. A wormhole in this context is not a bend within our brain, but a puncture through it, a tunnel that dips out of our plane of existence, travels through the higher dimensional bulk, and re-enters our brain at another point. This is a true higher dimensional shortcut. To visualize this, think of a vast sheet of paper representing our universe. Two dots on that paper might be far apart. A wormhole within the paper would be like folding the sheet to bring the dots together, but a bulk wormhole is different. It would be like a pencil punching a hole straight down through the first dot, moving through the three-dimensional room below the paper, and punching back up to emerge at the second dot. The journey bypasses the paper's surface entirely. The geometry of such an object would appear utterly bizarre to any three-dimensional observer. The entrance might not look like a simple sphere, but could exhibit impossible angles or shifting perspectives, as parts of the tunnel exist in dimensions we cannot perceive. Its creation likely ties directly to the universe's most violent birth pangs. In string theory's early universe, all dimensions, perhaps 10 or 11 of them, were compactified, curled up at a scale a billion times smaller than an atom. As the cosmos inflated, three spatial dimensions unfurled to become the vast expanse we know, while the others remained tightly wound. The first wormhole could have been a cosmic accident during this unfurling process. A flaw in the geometry, a tear in the fabric as dimensions separated, might have linked an unfurled dimension to a compactified one, creating a permanent fistula between realms. This gateway would be a relic of a time when all dimensions were equal, a scar from the moment our reality chose its shape. Travel through it would not just be a spatial leap, but a dimensional translation, moving through a corridor that exists partly in a space we are fundamentally blind to. A universe that hides its deepest wounds is a universe with rules. Roger Penrose's cosmic censorship hypothesis is one of physics' great unspoken laws. It proposes that nature abhors a naked singularity. Whenever a point of infinite density forms from gravitational collapse, like at the heart of a black hole, an event horizon must always cloak it. This horizon is a one-way veil, a point of no return that shields the rest of the cosmos from the unpredictable, lawless madness of the singularity itself. It is the universe's way of maintaining order, of keeping its most dangerous secrets locked away. Now, rewind to creation's first chaotic second. The formation of the first wormhole, according to many models, inherently involves singularities, the infinitely dense points at the heart of its structure, or pinched within its throat. But in that newborn, lawless cosmos, the usual safeguards might not have been in place. The 16th theory presents a staggering breach. The first stable wormhole was a cosmic censorship violation. It was a naked wormhole. Its singularities were exposed, visible, and accessible to the rest of the infant universe, completely unshielded by any protective event horizon. Picture a tunnel through spacetime where the walls are not smooth fabric, but are lined with points where gravity becomes infinite and the known laws of physics cease to have meaning. Anything approaching this object would not be quietly swallowed by a dark sphere. It would witness the raw, unmediated chaos of a singularity, a place where time and space trade meanings, where cause and effect unravel. The implications of such an object existing, even for a fraction of a second, are profound. Without an event horizon to contain it, the gravitational and quantum fury of the naked singularity would have radiated out into the cosmos unpredictably. It could have acted as a randomizer on a cosmic scale, spewing out particles or energy in bursts that defied any predictable pattern. More unsettlingly, it could have twisted the local flow of time into knots. In the presence of a naked singularity, closed time-like curves, those loops where you could travel back to meet your own past might form not in the hidden depths of a tunnel, but right out in the open. Causality itself, the foundational rule that cause must precede effect, could have broken down in the vicinity of this primordial anomaly. The region around this naked wormhole would have been a zone of pure physics without rules, a temporary bubble of anarchy in the settling cosmos. This was not a gentle gateway, but a screaming rupture in the ordered fabric reality was trying to weave. Its very existence would have imprinted a signature of chaos onto the surrounding matter and energy, a fossilized zone of statistical irregularity or bizarre particle paths that might still be detectable in the cosmic background today. The cosmic sensor, if it exists, would not have tolerated this for long. Perhaps the rapid expansion of the universe itself stretched and smoothed the anomaly, eventually cloaking the singularities in horizons and transforming the naked wormhole into a more stable, hidden structure. Or perhaps the flood of exotic matter needed to hold it open also served to dress the singularity, covering its nakedness and imposing order. But for one brief foundational moment, the universe may have stared directly into the heart of its own lawless potential, and the first gateway was that terrifying, unblinking eye. The universe's first lawless eye may have blinked, but what it saw was not a thing, but a relationship. The 17th theory dismantles our deepest assumption about travel. It proposes the first entity to traverse that primordial gateway was not a particle, not a wave of energy, but pure information. This is not data in the sense of bits and bytes, but quantum information, the fundamental state of a system, its most essential identity. In modern labs, we perform a trick called quantum teleportation. Here, the properties of one particle are instantaneously transferred to another distant particle, not by sending the particle itself, but by sending instructions to reconstruct its quantum state. The original is destroyed in the process, only its blueprint is transmitted. This feat relies on a pre-existing, spooky connection between the two locations, quantum entanglement. Now, scale this concept to the universe's first second. The infant cosmos was a superheated plasma, a dense soup where every particle was intimately connected to every other. The first stable wormhole, in this view, was not a tunnel for stuff to fall through. It was the universe's first dedicated quantum channel. Its formation created a direct pipeline between two vastly separated regions of the fiery plasma. Through this pipeline, the quantum state of one region could be perfectly teleported to the other. Imagine two vats of identically hot, dense primordial soup. The wormhole forms. Instantly, the precise quantum arrangement, the specific vibrations, spins, and entanglements of the particles in the first vat is read, transmitted through the geometric shortcut, and imprinted onto the particles in the second vat. No atoms moved. Instead, a pattern was copied. A correlation was established across a cosmic distance faster than light could have traveled the normal route. This event would have woven a thread of perfect synchronization into the fabric of the cosmos. The two regions, now sharing an identical quantum imprint, would evolve in lockstep, their fates forever linked. This theory finds a potential echo in our oldest map of the universe, the cosmic microwave background. This afterglow radiation from the Big Bang is remarkably uniform, but not perfectly so. It contains tiny, mysterious fluctuations, hot and cold spots. Some of these spots on opposite sides of the sky are correlated in ways that defy conventional explanation, as if they were once in contact, but are now far beyond each other's light horizons. A primordial wormhole acting as a quantum teleportation channel could explain this. It would have created those initial, impossible correlations, stitching a pattern of information into the cosmos before inflation blew those regions apart. The first traveler, then, was a whisper of connection, a single line of quantum code that helped write the first program for everything that followed. That whisper of quantum information established a pattern, but patterns can be fragile. The stability of our entire reality rests on a knife's edge. The 18th theory confronts a cosmic fragility known as vacuum decay. We imagine the vacuum of space as pure nothingness, but in quantum field theory, it is a seething, energetic state, the lowest possible energy configuration for our universe's particular set of laws. But what if our vacuum is not the true lowest? What if it is a false vacuum, a precarious plateau, and a lower energy state lies beneath us? The shift from a false vacuum to a true vacuum is not gradual. It is a catastrophic, instantaneous quantum tunneling event. A microscopic bubble of the lower energy vacuum could spontaneously form somewhere in space. This bubble would then expand at nearly the speed of light in all directions, its wall a boundary of unimaginable energy. Everything this wall touches, every atom, every force, every law of physics as we know them, would be permanently and violently rewritten into a new, alien state. The universe inside the bubble would be fundamentally different from the universe outside. Now, rewind to the first instance after the Big Bang. The cosmos was a hot, dense soup of fields settling into their configurations. In that turbulent era, the risk of such a vacuum decay event was astronomically higher. The 18th theory proposes that the universe's first stable wormhole was not a tunnel through space, but the tunnel of decay itself. It was the boundary wall of a vacuum decay bubble that formed, but with a twist. Instead of expanding outward in a sphere to consume everything, the geometry of the newborn cosmos caused this bubble wall to stabilize, to pinch off and form a closed loop. This created a permanent conduit, a wormhole. One mouth of this tunnel would exist in a region of spacetime governed by one set of physical laws, perhaps our own familiar physics. The other mouth would open into a region governed by the new, lower energy laws of the decayed vacuum. The wormhole itself, the throat, would be the scar of that transition, a frozen moment of cosmic rewriting. Traveling through it would not merely be a spatial journey, but a transit between two entirely different realities with different fundamental constants. The speed of light, the strength of gravity, the very existence of certain particles could change from one side to the other. This primordial object would be a fossil of a choice the universe almost made, a permanent bridge between what is and what could have been. Its existence would be a haunting reminder that our physics are not absolute, but merely one possible arrangement in a landscape of potential realities, and that the first gateway was a snapshot of the cosmos changing its own rules. Our cosmos may have been born from a collision of titans. The 19th theory draws from the ekpyrotic universe model, a radical alternative to the traditional Big Bang story. In this vision, our three-dimensional reality is not an expanding bubble from a single point, but a vast membrane, or brain, floating within a higher dimensional space. Nearby, there existed another such brain, a parallel cosmic sheet. These two colossal structures were drawn together by gravity across the bulk, moving slowly until they finally collided. That collision was not a destructive crash, but a creative one. The immense kinetic energy of the impact was converted into the searing heat, light, and matter that filled our brain. This, the theory proposes, was our Big Bang, not a beginning from nothing, but a rebirth from contact. Now, consider the aftermath of such a universe-shattering event. When two elastic sheets collide and then bounce apart, they do not always separate cleanly. They can remain connected by strands of material, like two pieces of hot, sticky taffy pulling apart, but leaving a stringy bridge between them. In the ekpyrotic scenario, the first wormhole could be precisely that, an umbilical cord, a remnant filament of spacetime that did not sever when the brains recoiled. This would not be a wormhole in the conventional sense of a tunnel within our universe. It would be something far more profound, a cosmic scar that is also a living connection. One mouth of this tunnel would be anchored in our brain, the reality born from the collision. The other mouth would remain tethered to the other, parent brain. This makes it a bridge not just between two points in space, but between two entirely distinct cosmological structures, two separate universes that briefly touched and gave birth to everything we know. The implications are staggering. This primordial wormhole would be a permanent backdoor to the realm that fathered our own. Any energy, information, or even physical laws that differ between the two brains could, in theory, still seep through this ancient conduit. It would be a geological fault line in the foundation of reality, a place where the boundary between our world and its sibling is thin and permeable. Finding such an object would be the ultimate archaeological discovery, a direct link to the event that set our entire cosmic history in motion. Magnetism is a force we take for granted, but it hides a fundamental asymmetry. Every magnet we have ever found, from a simple refrigerator magnet to the core of our planet, is a dipole. It always has a north and a south pole, two ends that cannot be separated. Break a bar magnet in half, and you do not get isolated poles. You simply create two new, smaller magnets, each with its own north and south. This duality is woven into the equations of electromagnetism. Yet many of our deepest theories of physics whisper that this was not always so. In the unimaginable heat of the universe's first moments, a split second after the Big Bang, a profound symmetry reigned. The electromagnetic force and the weak nuclear force were one and the same, a unified electro-weak force. As the cosmos cooled, this symmetry broke, freezing the forces into the separate entities we know today. Grand unified theories, which attempt to stitch together all fundamental forces, predict that an even earlier, more profound unification existed, and within the mathematics of that majestic symmetry lies a prediction: particles with a single magnetic charge should have been born. These are magnetic monopoles, not dipoles, a north without a south, or a south without a north, a solitary point of pure magnetic charge. They are hypothetical fossils, relics that should have been created in abundance during that first cosmic phase transition and then scattered across the expanding universe like rare diamonds in the ash of a cooled fire. Their magnetic charge would be colossal, billions of times stronger than the dipole magnetism of an atomic nucleus. Now, picture a storm of these particles in the infant cosmos. Theory 20 proposes that where these monopoles gathered in a dense knot, their combined influence did something extraordinary. Their immense, aligned magnetic fields would have been so powerful they did not just interact with other particles. They began to grip the fabric of spacetime itself. According to Einstein's equations, energy and mass warp geometry, and a magnetic field is a form of concentrated energy. A swirling vortex of these monopoles, with their titanic magnetic charges, would have twisted the local spacetime into a profound, spiraling knot. The geometry could have folded so severely that it punctured, stitching a tunnel between 2 points. The first stable wormhole in this view was not carved by gravity alone, but forged by magnetism of a primordial and pure kind. It was a magnetic tornado in the fabric of reality, a gateway powered by the universe's first and most perfect magnets. The journey through such a tunnel would have been a voyage along lines of cosmic force, a passage where the very concept of magnetic north lost all meaning because you were traveling inside the source. That magnetic tornado in spacetime twisted more than just space. A wormhole's strangest property is not where it goes, but when. According to the rigorous mathematics of general relativity, any traversable wormhole carries a startling, almost automatic feature: the potential for time travel. This is not a speculative add-on, but a direct consequence of motion and gravity. If you take one mouth of a stable wormhole and move it at high speed relative to the other, or place it in a stronger gravitational field, time will pass at different rates at each entrance due to the effects of relativity. This creates a time offset. Synchronize two clocks, put one at each mouth, move one mouth on a high-speed journey, and when you bring them back together, the clocks will disagree. The wormhole now connects not just two places, but two different moments. If the moving mouth's clock reads an earlier time, walking through the tunnel from that end would send you into the relative past of the stationary end. You have built a time machine. Now, apply this chilling logic to the universe's first wormhole, born in a cosmos of unimaginable violence. In those first fractions of a second, the fabric of reality was not a placid stage. It was a storm. Different regions expanded at slightly different rates, were tugged by different densities of matter and energy, and experienced gravitational tides of ferocious strength. The two ends of a newly formed wormhole would not have been sitting calmly in a uniform cosmos. They were instantly subjected to wildly different conditions. One mouth might have been caught in the wake of a colliding cosmic string, jerked to relativistic speeds. The other might have been anchored near a knot of primordial dark matter, submerged in a deeper gravitational well. From the very instant it stabilized, a time differential would have been etched into its structure. The first traversable wormhole was not just a bridge in space. It was, by the ironclad rules of Einstein's physics, a natural time machine from its first moment of existence. This has staggering implications for causality, the chain of cause and effect that structures our reality. A universe containing such an object from birth is a universe where the timeline was never a simple, linear thread. Events in the cosmic infancy could have been influenced by information or energy looping back from a fraction of a second in the future. A particle could exit the wormhole and become part of the very process that stabilized the tunnel, creating a self-consistent loop where the effect helps secure its own cause. The chaotic conditions of the early universe provided the perfect, violent laboratory to crank one end of that first gateway through time, weaving the possibility of temporal loops directly into the foundation of everything. Our history may not be a straight line from a beginning, but a braided cord, with its first threads tied into a knot at the dawn of time. The braided cord of time suggests a cosmos born from connection, not isolation. This leads to a theory where the universe itself has a family tree. The 22nd theory proposes that the first wormhole was not a tunnel, but an umbilical cord. In this biological metaphor, our entire cosmos was once a nascent baby universe, connected to a vast, mature parent reality. This cord was a wormhole, a lifeline woven from the fabric of spacetime itself. Through it, the parent universe did not just give birth to ours in a singular event, it nourished it. The transfer was not of matter in the conventional sense, but of something more fundamental. Imagine the cord pulsing with inflationary energy, the very force that caused our universe to expand explosively in its first moments. This energy, channeled from the parent, could have been the direct cause of our Big Bang, a controlled infusion that set our dimensions unfurling. Alongside this energy, the cord might have transmitted the seed patterns of quantum fluctuations, those microscopic ripples in the quantum fields of the early cosmos, which later grew into galaxies and clusters, might not have been random. They could have been inherited, a genetic blueprint of structure passed from one reality to another. The moment of the first travel through this wormhole, then, was not a voyage by any creature. It was the universe's first heartbeat, the inaugural pulse of energy and information flowing from the parent to the child, this connection could not last forever. For our universe to become its own independent entity, the cord had to be cut. Perhaps the flow of energy created a kind of cosmic scar tissue, a region of such intense gravitational stress that the throat of the wormhole pinched shut permanently. Or perhaps the rapid expansion of our infant universe simply stretched the cord until it thinned, snapped, and recoiled into both realms. The severing would have been a pivotal moment of cosmic independence. But what happened to the scar? The theory offers a breathtaking possibility. Our end of that severed umbilical cord, the point of attachment where our universe was once fed, did not simply vanish. It remained as a profound gravitational wound in the fabric of our newborn reality. As matter coalesced in the eons that followed, this region, already possessing an immense, innate curvature from its role as a cosmic nexus, would have acted as a gravitational anchor. It would have drawn in the first waves of primordial gas and dark matter, feeding on them faster than anywhere else. This scar, this fossilized mouth of the first wormhole, could have grown into the very first supermassive black hole in existence. And it might still be with us today, not as a gateway, but as a silent, dark heirloom at the center of our own galaxy, the supermassive black hole known as Sagittarius, a star, lurking in the heart of the Milky Way, could be the sealed remnant of our universe's birth cord, a monument to our cosmic ancestry. A single bridge is a curiosity, but a network is an architecture. The 23rd theory transforms our perspective from a solitary gateway to a cosmic blueprint. It suggests the first traversable wormhole was never meant to be alone. It was the foundational seed, the very first node in what would become a vast, invisible lattice woven through the expanding cosmos, a fractal network of spacetime shortcuts. This idea begins with the quantum foam of the earliest universe, that churning sea of virtual wormholes blinking in and out of existence. In most models, they all vanished. But in this view, one did not just stabilize, it triggered a cascade. The immense energy released or the unique geometry of that first stabilized tunnel could have acted as a nucleation point, like the first crystal forming in a supercooled liquid. It created a localized instability in the fabric of spacetime that made the formation of a second, connected wormhole more likely nearby, then a third and a fourth, each new tunnel finding a connection to the growing web. The network did not form all at once. It grew organically as the universe itself expanded, like frost crystals spreading across a window pane. The pattern of connections branched and replicated according to the underlying mathematical rules of quantum gravity, creating a self-similar, fractal structure across scales. The first journey through this system, then, was not a single transit from point A to point B. It was the inaugural establishment of a route within a nascent transportation grid. A particle or ripple of energy passing through that first node would have had its path instantly multiplied, its influence echoing through the budding network, testing the first connections in a system destined to become universe-spanning. This theory offers a breathtaking explanation for one of modern cosmology's most beautiful observations, the cosmic web. Today, we see galaxies not scattered randomly, but strung along vast filaments of dark matter and gas, with enormous empty voids between them. What if that web is not just made of matter, but of structure? The fractal wormhole network, seeded in the first instance and stretched to macroscopic scales by inflation, could have provided the original skeleton. The great filaments where galaxies now cluster might trace the paths of ancient, super-stretched wormhole throats, regions of spacetime, so warped they naturally funneled and attracted the first clouds of primordial hydrogen. The voids, those immense cosmic deserts, could be the spaces between the threads of the network, areas largely untouched by this underlying architecture of shortcuts. The luminous galaxies we see would be mere streetlights along hidden, gravitational highways built at the dawn of time. This means the first wormhole was not a destination, but a genesis point for the hidden framework of everything. Ghosts built the first bridge. In the universe's first second, it was not stars or planets that dominated, but a flood of phantom particles called neutrinos. Trillions upon trillions of them streamed through every cubic inch of the searing plasma, so intangible they could pass through a light year of lead without a single collision. They were the universe's silent, overwhelming majority. Theory 24 proposes that this ghostly tide was not just a passive backdrop, but the active architect of the first gateway. To understand how, we must shift our thinking about gravity. We are used to the idea that mass warps spacetime like a bowling ball on a trampoline, but gravity is not generated by mass alone. It is generated by energy and momentum as well, a truth enshrined in Einstein's equations, and in those first moments, neutrinos carried an unimaginable amount of energy. They were not the low-energy ghosts we detect from the sun today. They were primordial, born in the inferno of the Big Bang itself, and they moved at velocities indistinguishable from the speed of light. Now imagine not just a random sea of these particles, but a coordinated current. In the turbulent early cosmos, vast streams of ultra-high-energy neutrinos could have been channeled by pressure waves in the plasma, flowing in a coherent river light years wide. This was not a river of matter, but a river of pure, concentrated momentum. According to general relativity, such a concentrated flow of energy momentum would itself warp the fabric of spacetime around it. This is sometimes called the neutrino shadow effect, where the collective gravitational influence of the stream creates a wake in the geometry of the cosmos. If two such immense, coherent streams were to cross or flow in parallel at just the right angle, their combined gravitational shadows could have interacted in a profound way. The spacetime between them might have been pinched and folded, not by the pull of a massive object, but by the sheer kinetic pressure of these ghostly projectiles. In a rare, perfect alignment, this folding could have become so extreme that the fabric punctured, stitching a temporary tunnel between the regions feeding the two streams. The first wormhole, then, was not carved by mass, but by motion. It was a scar left in spacetime by the universe's most elusive particles in their moment of supreme power. And the first journey through it was a case of the builders becoming the first passengers. A pulse of those very same ultra-high-energy neutrinos, flowing along their natural current, would have encountered this newly formed geometric shortcut. Without slowing or changing, the lead portion of the neutrino stream would have simply taken the shorter path, slipping through the tunnel their own collective energy had just carved. They would have arrived at a distant point in the young cosmos, not by traveling the long way around, but by surfing the warp in the fabric they themselves created. It was a perfectly closed loop. The cause and the traveler were one and the same. This ghostly highway would have been ephemeral, lasting only as long as the coherent neutrino current maintained its structure. Once the early universe expanded and cooled, the neutrinos lost their immense energy, their streams dissipated, and the delicate warp in spacetime likely healed shut. But for one fleeting instant, the most intangible things in existence became the master engineers of reality, proving that even phantoms, in sufficient numbers and with enough speed, can bend the universe to their will and open a door through nothingness. Every ending may contain the seed of a new beginning. Some of the most profound cosmological models propose our universe is not the first and only act in the cosmic play, but merely the current scene in an endless cycle. In theories like conformal cyclic cosmology, the universe does not have a singular, absolute beginning. Instead, it undergoes eternal rounds of expansion and cooling, followed by a contraction into a hot, dense state, only to rebound in a new Big Bang. Each full round is called an eon. In this majestic, cyclical view, the first stable wormhole in our eon carries a history that shatters our linear sense of time. It is not a newborn structure from our own Big Bang, it is a survivor, it is a relic from the previous cosmic cycle, a piece of space-time architecture that endured the unimaginable violence of a big crunch and the subsequent fiery rebirth. Picture the universe of the previous eon, filled with its own stars, galaxies, and perhaps civilizations, all destined to be drawn back together in a gravitational cataclysm. As that cosmos contracted, most structures would be torn apart, their information scrambled in the ultimate heat death before the bounce, but the geometry of a stable wormhole, especially one held open by exotic matter or cosmic strings, possesses a unique topological resilience. It is a knot in the fabric of reality itself. As the previous universe collapsed, this knot might not have unraveled. Instead, the intense gravitational pressures could have forced it into a kind of suspended animation, a frozen geometric state that persisted even as the space around it was crushed to a singularity and then exploded outward once more. When our universe burst forth in its own Big Bang, this ancient knot was there, woven into the newborn fabric from the very first instant. It was not created in our fireball, it was inherited. This makes the object unimaginably ancient, older than time as we measure it. It is a direct window, a permanent scar that stitches our reality to the one that came before. The first journey through it in our cycle, then, would have been a passage not just through space, but through deep time. Any particle or ripple of energy that traversed it in our universe's infancy would have moved through a corridor that witnessed the death of an entire cosmos. The geometry of its throat might still bear the imprints of that previous eon subtle gravitational waves from long-vanished collisions, or a faint, fossilized signature of different physical constants. Finding and studying such an object would be the ultimate act of cosmic archaeology. We would not be probing the first moments of our universe, but the final moments of its predecessor, reading a history written in the twisted fabric of a bridge that has outlived its own creators. This wormhole would be a silent monument to eternity, a testament that even the universe itself may be mortal, but some structures within it are built to last forever. That inherited bridge from a prior cosmos suggests a universe built on memory, but what if the first memory was not of an event, but of being witnessed? The 26th theory ventures into the most speculative frontier where physics meets philosophy. It proposes the first wormhole was not a tunnel for matter, but a gateway for mind. This idea draws from a radical interpretation of quantum mechanics, where the very act of observation does not merely measure reality, but helps to create it. In this view, particles exist in a haze of probabilities until a conscious observer looks, forcing the quantum wave to collapse into a definite state. Now push this concept to the absolute beginning. Before stars or planets, what could possibly serve as an observer? The theory suggests the universe itself. In its first chaotic moments, the cosmos was a superposition of every possible state, a quantum soup of infinite potential. The emergence of the first stable wormhole was not a random accident of energy or geometry. It was the universe's first act of self-observation, a nascent form of cosmic consciousness, perhaps a coherent quantum system within the primordial fireball, achieved a state of integrated information, a first flicker of perception. This act of looking inward, of the cosmos perceiving its own existence, caused a fundamental collapse. The infinite possibilities of quantum foam resolved, and in that resolution, the fabric of spacetime was not just smoothed. It was threaded. The intense focus of that first observational event warped probability itself, stitching a tunnel through the quantum haze as a permanent conduit for perception. The wormhole became a literalized connection, a feedback loop where the observer and the observed were linked by a shortcut in reality. The first journey through this gateway, then, was not a transit of particles, but a leap of awareness. That initial cosmic consciousness did not send a probe, it extended its perception. Through the wormhole, it could perceive regions of itself that were otherwise causally disconnected, integrating information across vast distances instantaneously. This gateway was not for travel, but for understanding, a sensory organ woven into the universe at the moment it became aware of its own existence. While this theory borders on science fiction, it raises a haunting question rooted in quantum foundations. If observation plays any role in shaping reality, then at the scale of the universe's birth, the observer and the observed were one and the same. The first wormhole might be the scar of that primal act of self-creation, a permanent monument to the moment the cosmos opened its eyes and, in doing so, opened a door within itself. The cosmos did not simply cool from a fireball into our familiar reality, it crystallized. In the universe's first fleeting moments, the fundamental forces were unified into a single, perfect symmetry. Then, as the temperature plummeted, that symmetry shattered in a series of cosmic earthquakes known as phase transitions. Think of water freezing into ice. The liquid state is symmetric, it looks the same in every direction, but when ice crystals form, they choose a specific alignment, breaking that symmetry and releasing latent heat in the process. The early universe underwent transformations far more profound. One of the most critical was the electroweak transition, occurring when the universe was just a picosecond old. Here, the electromagnetic force and the weak nuclear force, which had been one and the same, split apart forever. This divorce of forces released a staggering amount of latent energy into the fabric of spacetime. And just as ice can form with cracks or air bubbles trapped inside, the universe's rapid freezing was not flawless. When a field like the Higgs, which gives particles mass, settles into its new state, it does not do so uniformly everywhere at once. Different regions of the cosmos could have chosen slightly different orientations for this new vacuum state. Where these mismatched regions met, the field could not smoothly reconcile. The boundary between them became a defect, a fault line in the very structure of reality. These are topological defects, cosmic strings, domain walls, or magnetic monopoles, objects predicted by our theories but not yet observed. Theory 27 proposes that the first stable wormhole was exactly this, a topological defect born from a phase transition. It was not a tunnel carved by gravity or motion, but a knotted configuration in the quantum vacuum itself, a crack in the Higgs field that got frozen into place as spacetime cooled. Imagine the universe's fabric setting like concrete. If you tie a knot in a rope and then pour concrete around it, once the concrete hardens and you remove the rope, the knot shape remains as a hollow tunnel in the solid block. In a similar way, as the universe underwent its electroweak transition, a region of spacetime could have become twisted into a self-sustaining loop. The immense energy released by the transition itself could have provided the exotic matter-like pressure needed to stabilize this knot against gravitational collapse, propping it open from the very moment of its creation. This wormhole would be a fossilized tremor from the instant the forces of nature chose their separate paths, a permanent scar from the moment light and radioactive decay became distinct phenomena. Its geometry would be dictated not by chance, but by the mathematical rules of symmetry breaking, making it a direct, physical record of one of the universe's most pivotal steps toward complexity. Amidst all the grand designs and cosmic purposes, there lies a profoundly simple possibility. The first journey through a wormhole was not a pivotal event scripted into the universe's foundation. It was a fluke, a cosmic happenstance of staggering insignificance. This theory strips away the notions of destiny, fine-tuning, or observation. It argues that the first stable wormhole, regardless of how it formed, sat empty and unused in the chaos of the early cosmos. It was a bridge to nowhere, a silent architectural quirk in the newborn universe, unnoticed and irrelevant. Then, by sheer, unadulterated chance, something drifted into it. This was not a guided probe or a conscious entity. It was likely a random quantum particle, a nameless fragment of the primordial fireball, or a clump of dark matter that had not yet found a galaxy to call home. Perhaps it was even a solitary ripple of gravitational waves from some distant, forgotten collision in the infant cosmos. This object was not seeking a shortcut. It was simply moving along its path, governed by the blind laws of physics, when its trajectory intersected with the precise point in spacetime that was the wormhole's entrance. It entered at just the right angle and with just the right energy to avoid being torn apart by tidal forces, slipping into the throat not by design, but by a statistical roll of the dice. In that instant, it became the universe's first accidental traveler. It passed through the geometric shortcut and emerged somewhere else, or someone else, completely unaware of the milestone it had just achieved. The journey left no trace, set no precedent, and initiated no grand cycle. The particle, if it was even matter at all, likely continued on its way, its path forever altered by a random encounter with a cosmic pothole. This theory of cosmic luck is both humbling and liberating. It suggests that the most profound structures in reality can exist without purpose, and that history's first chapters can be written by chance. The universe's inaugural gateway may have opened, waited in the silence, and closed again, its only witness a single, oblivious bit of reality that stumbled through it and vanished into the expanding dark. But that random, forgotten particle did not drift through empty space. The space it moved through, the very rules that governed its motion, were already in place. We assume the laws of physics are the stage upon which the cosmic drama unfolds, fixed and eternal. Theory 29 flips this script entirely. It proposes the stage itself was built by the first performance. The laws of physics as we know them, the speed of light, the gravitational constant, the strength of the nuclear forces, are not fundamental truths written on some cosmic tablet. They are emergent properties, side effects that crystallized from the structure and stability of the universe's first wormhole. In this view, the primordial gateway was not an object within the cosmos. It was the mold that shaped the cosmos, its internal geometry, the specific curvature of its throat, and the exotic matter holding it open, created a resonant cavity for reality. As the fiery chaos of the Big Bang expanded and cooled, it was forced to conform to the shape of this pre-existing, stable structure. The wormhole's geometry acted as a filter, a set of boundary conditions that allowed only certain vibrational patterns, certain relationships between energy and spacetime, to persist. The speed of light, for instance, might not be a universal speed limit decreed from on high. It could be the natural propagation rate of information through the geometric lattice of that first wormhole's stretched fabric, a speed limit inherited by the entire universe that formed around it. The precise strength of gravity could be a direct readout of how severely the wormhole's throat warped spacetime, setting a baseline curvature that everything else would follow. Even the quantum fuzziness at tiny scales might echo the turbulent quantum foam that birthed the tunnel itself. The first travel through this object, then, was not a journey by any particle or wave. It was the calibration event. It was the process by which the seething, lawless energies of the newborn universe first encountered this stable geometric template and were forced to align with it. Imagine tuning a radio through static until you suddenly hit a clear, strong signal. The chaotic frequencies of the early cosmos tuned themselves to the resonant frequency of the wormhole, and in that moment of alignment, the static resolved into the coherent laws we now take for granted. The consistency we see across the cosmos, the fact that gravity works the same in a distant galaxy as it does here, is not a mystery, it is a memory. It is the lingering echo of that single, universe-spanning structure that imparted its geometric rules to every region it touched. We do not live in a universe that contains wormholes, we live in a universe that is, in a very real sense, the aftermath of one. Our predictable, rule-bound reality is the permanent signature of that first, stable knot in the fabric of everything. We have followed the trail of possibilities back to the very first instant of existence, only to find a door that opens not from the past, but from the future. This final theory proposes a staggering reversal. The universe's first traversable wormhole has not happened yet. It does not lie in the quantum foam or the fires of the Big Bang. It awaits us in the deep future, as a monument to a civilization that will one day command the power to stitch the fabric of spacetime itself. This is not a natural formation, but the ultimate engineering project of a universe-spanning intelligence, perhaps our own descendants, who have mastered physics to a degree we can barely dream of. They will not find a wormhole, they will build one, forging the first true gateway from raw energy and geometry. From our perspective here in the cosmic past, this event is still to come. Yet, the nature of wormholes themselves may shatter this simple linear sequence. A traversable wormhole, by its very physics, is a machine for bending time as well as space. If one mouth of this future-built wormhole is then taken on a relativistic journey or placed in an intense gravitational field, a time differential will be etched into its structure. That future mouth could become a gateway to our own present, or even to our deep past. The moment of its completion in the far future could, from our point of view, be the moment a tunnel opens in our ancient sky. This creates a paradox of breathtaking elegance. The first use of the wormhole could predate its own construction. A signal, a probe, or even a traveler from that future civilization could step through their new gateway and arrive in an era before their great-great-grandparents were born. They would not be visiting history, they would be writing it from the end. Their very arrival could send ripples back through time, subtle influences embedded in the cosmic background radiation or guiding the paths of the first particles. Those strange quantum correlations or unexplained fluctuations we search for in the early universe might not be relics of a natural birth, but the faint, retroactive echo of a project whose groundbreaking ceremony has not yet occurred in our timeline. The universe's first stable wormhole, then, is a closed loop in time. It will be built because its effects have already been felt. Its existence is a promise from the future, a message in a bottle sent upstream through time, telling us that the cosmos is not just a story with a beginning. It is a story whose ending reaches back to touch its own opening chapter, completing a circle that makes the first journey and the last act of creation one and the same. That final paradoxical loop brings our thought experiment full circle. We have journeyed across 30 staggering possibilities from the universe's first breath to its final act. We have seen wormholes as cosmic birth canals, as scars from inflationary storms, and as handshakes between colliding singularities. We have watched them be woven from quantum foam, forged in the fires of symmetry breaking, and threaded by the ghostly tides of primordial neutrinos. They have been fossils of a prior cosmos, blueprints for our laws of physics, and perhaps even monuments to a future civilization reaching back to touch its own beginning. Each theory, from the wildly speculative to the mathematically grounded, paints a different portrait of that inaugural gateway. It might have been a purposeful channel for fine-tuning, a random crack used by a single oblivious particle, or the universe's own first act of self-perception. The sheer breadth of ideas reveals something profound. Wormholes are not just a single puzzle in astrophysics, they are a nexus, They sit precisely at the most thrilling frontier human knowledge possesses, the razor's edge where established, tested physics meets the boundless terrain of legitimate speculation. On one side, we have the ironclad equations of Einstein, the bizarre confirmations of quantum mechanics, and our growing understanding of the cosmos' infancy. On the other, we have questions that stretch our imagination to its limit. Exploring that frontier, even through thought experiments, is never a waste. It forces us to confront the deepest mysteries of existence, of time, of causality, of our own place in a potentially layered reality. We may never know which, if any, of these 30 visions reflects the truth of that first impossible journey. But the search itself expands the realm of what we consider possible. It reminds us that the universe's history is still being written, not in stone, but in the fertile ground of human curiosity. So we turn the question to you: after this voyage from quantum foam to cosmic civilizations, which theory reshaped your mind? Did the idea of an inherited black hole at our galaxy's core haunt you, or did the elegant loop of a self-creating time machine captivate your imagination? Perhaps you have a theory of your own, a thread we haven't yet pulled. The conversation is the true destination. Share your thoughts in the comments below, and if you crave more deep dives into the fabric of reality, be sure to subscribe. Our next journey into the cosmic unknown is already waiting.